Hi everyone. Let's take a look at three examples for naming cycloalkanes. Just a quick review of the naming rules. Because they're single bonded, they name with ane. We're going to use a number prefix to show how many carbons there are in that ring structure, in the cyclical structure. We're going to have cyclo as a part of the name too, cyclo, and then the prefix, and then ane. We're going to deal with branches in our normal way, but the numbering has two extra things to worry about. If there's only one branch, we're not going to use a digit. If there are multiple branches, we have to start numbering, add a branch, and go whatever direction we need to, clockwise or counterclockwise, so that the numbers end up as small as possible. Here's a few examples. This first one, it has a 4-carbon ring. It looks like a square, and there's this one extra carbon branch attached to it. So I see single carbons, single bonded carbons. I don't see any double or triple bonds or anything like that. And it's 4 carbons. 4 carbons in a ring structure. The root here is going to be cyclobutane. Single bonded carbons, how many of them? 4. Bute. Do they make a ring? Yes. Cyclobutane. Now we have this alkyl group, a branch, right there. That branch has 1 carbon in it. We're going to name it in a traditional way. 1 carbon is methyl. Interestingly, if there's only 1 branch, then we do not use a digit. So the final name for this first example is methyl cyclobutane. A second example, this one has 2 methyls attached to a 6-carbon ring. And that ring has only single bonded carbons. Single bonded carbons, the name is going to end with ane. It's 6, so we need the prefix for that, which is hex. We're going to put a cyclo on there because it's a ring of 6 single bonded carbons. Let's get that part down. Cyclohexane. But then there's a methyl right here and a methyl down there. 2 of the same kind of branch. 2 branches, each with 1 carbon. A branch with 1 carbon is called methyl, but we have 2 of them, so we're going to say di. We add that at the front. Now we're looking at dimethyl cyclohexane. Let's think about the numbering system. If there's 2 or more branches, 2 of the same kind of branch or 2 different kind of branches doesn't make a difference. If there are multiple branches, start numbering at a branch. That means it doesn't matter which branch we choose, that branch is going to be attached to carbon number 1. Start numbering at a branch. Here I have 2 different branches. It does not matter where I start. And I call that carbon number 1. Now we're going to count clockwise or counterclockwise so the digits are as small as possible. So I have an option to go counterclockwise. If I did that, this would be carbon number 1, 2, 3, 4, 5. If I start on that carbon and I go counterclockwise, we get a 1 and a 5. But if I start at this carbon and I go clockwise, we get 1, 2, 3. We get a 1 and a 3. And a 1 and a 3 is definitely smaller than a 1 and a 5. So we get those numbers in. We have here 1,3-dimethyl cyclohexane. Our last example has 2 different branches. But let's focus on the main root part first. We have single bonded carbons. We need a prefix, and we're going to get cyclo in there. Here I see single bonds in a 5-carbon ring structure. We have cyclopentane. Cyclopentane. Single bonded carbons, 5 of them in a ring. Cyclopentane. Now we have up here a methyl and a second branch that has 2 carbons in it, 2-carbon branch ethyl. We have to name these alphabetically, so the ethyl is going to come first in the name before the methyl. Now, the last step is to assign some numbers to these 2 branches. Start numbering at a branch. Does not matter which branch you start numbering at. Choose a branch and call it attached to carbon number 1. Here, I'm going to go like this in my red. I'm going to call that one right there number 1. Clearly, I hope that we're going to get smaller numbers if we count in a clockwise direction. The end result of this is that this chemical, we have the 1 on the methyl, 2 over here on the ethyl. We have 2 ethyl, 1 methyl, cyclopentane. Let's look at that name in reverse. Single bonds between 5 carbons, pent, in a ring, cyclo. There is a branch, methyl, a 1-carbon branch. It's attached to carbon number 1 of the main ring structure, and attached to carbon number 2 is a 2-carbon branch, ethyl. When we work through the process of naming cycloalkanes, we're always working from back to front. It's our traditional method. It's really tempting to overlook this important couple of syllables, cyclo. Let's look at our 3 examples one more time. A 1-carbon branch on a 4-carbon ring structure, methyl cyclobutane. Because there was only 1 branch, we did not include a number there. There's not a digit out here at the front, it's just methyl cyclobutane. Our method of dealing with the naming process of branches is always the same. A 1-carbon branch is methyl, a 2-carbon branch is ethyl. If we have 2 of the same type of branch, then we say di. This example had 2 different methyls attached to a 6-carbon ring structure. After we named one of the branches and counted it as carbon number 1, we ended up going counterclockwise to arrive at 1,3-dimethyl cyclohexane. And our final example that had 2 different branches, we're still going to name those branches alphabetically, with ethyl always coming before methyl. Our end result for the last one was 2-ethyl, 1-methyl cyclopentane. And I hope that helps.